go. All right, that's probably better. Let's do this just a little bit. And oh yeah, all right, cool. Oh, welcome to another night of Advent of Code, folks. If you saw me last night, you knew that that was incredibly difficult. It took me 3 hours to solve part 1. I did eventually get to part 2. Let's take a look at our leaderboard, see if anybody's caught up from either things. My guess is no, though. Kevin Chuck caught up. He did last night's. I'm impressed, Kevin. I mean, still 150 points behind, but that's okay. Still, good job. If I had put my money on anybody, it would have been Brian Kendall. And, yeah, of course nobody's here. Yeah, so tonight, the plan is to try and finish just in time for 10:25 p.m. my time. Starts at 9 p.m. Want to get under an hour and 25 minutes because that'll give me just enough time to finish up, hop in the car, and drive to McDonald's before it closes at 11 p.m. about a half an hour away. Go get a nice little nighttime treat, but I only get to do that if I solve the problem quickly. Now, if we look at yesterday, yesterday was really slow, actually. So even though it took me 3 hours, I was on the 1800th versus, you see, yeah, this one I had to start late because I was coming in from somewhere else. But in general, like this 3400 was 40 minutes in. And if we look at the overall stats of like who finished, yeah, only 7,000 people solved this problem. So yesterday's was really hard. You know, shouldn't feel bad about not getting that far. It seems like day 16 was the real drop off, which we go back and look. Day 16, oh yeah, the elephants in the tunnels. It's a graph search. So unsurprising. Let's see, what are the other big drop offs? So day 1 to day 2, day 2 to day 3, fine. We expect there to be a curve. 5 and 6 were fine. What was day 7 that pulled people off? Oh, the file tree, sure. And looks like day 9 was pretty rough. Oh, simulating the rope, sure. And day 12 was another one. Oh, simulating walking up the path, sure. Okay, so not all that surprising. And then yeah, another jump at 16, and then another little jump at 15. Like only half as many people have solved as the day before, which is kind of surprising. But day 18 was pretty chill. So I'm hoping not for too chill of a day. It'd be nice if it took an hour. If everything took an hour, I'd be pretty happy. And if we take a look at my personal stats, yeah, everything took under an hour except for this one where I started late, and looks like it took about an hour and 40 minutes, and this one. So everything's, well, I guess we should be looking at this. So everything's taking under an hour. This one took just over an hour, which would be fine. Same. This one was rough. This one was rough, and this one was rough. So only 3 out of 19 so far have taken over an hour. Well, 5, 4, 3, 2, 1, and here we go. Day 20, Grove Positioning System. It's finally time to meet back up with the elves. When you try to contact them, however, you get no reply, perhaps out of range. You know they're headed to the grove where the starfruit grows, so if you can figure out where that is, you should be able to meet back up with them. Fortunately, your handheld device has a file, your puzzle input, that contains the grove's coordinates. Unfortunately, the file is encrypted, just in case the device were to fall in the wrong hands. Maybe you can decrypt it? While you were still back at camp, you overheard some elves talking about the coordinate file encryption. The main operation involved in decrypting the file is called mixing. The encrypted file is a list of numbers. To mix the file, move each number forward or backward in the file a number of positions equal to the value of the number being moved. The list is circular, so moving a number off one end of the list wraps around to the other end, as if the ends were connected. For example, to move 1 in a sequence like this, moves 1 position forward. To move -2 in a sequence like this, you wrap it around, so before 9. The numbers should move in the order they originally appear in the encrypted file. Numbers moving around during the mixing process do not change the order in which the numbers are moved. Consider this encrypted file. 1, 2, -3, 3, -2, 0, 4. Initial arrangement, we move 1 forward, we move 2 forward, we move -3 backward, we move 3 forward, we move -2 backwards, 0 doesn't move, and 4 moves forward. Then the grove coordinates can be found by looking at the 1000th, 2000th, and 3000th numbers after the value 0, wrapping around the list as necessary. In the above example, the 1000th number after 0 is 4, 2000th is -3, and 3000th is 2. Add these together produces the sum 3. What is the sum of... what is the sum of the 3 numbers that form your grove coordinates? So this seems like a pretty easy implementation problem. Okay. Alright. So... let's see. Java list insert in between. Sorting an item in between two items. Specify the position with the element we add to the list. Inserts the specified item at the specified position in this list. Shifts the element current to that position, and any subsequent elements to the right. Adds one of the indices. Okay, I'm trying to think. So all the remaining items are always going to remain in the same order. Because whenever we're going from left to right, no matter where we insert these, all the other items are going to like stay in order no matter how they get separated. There's no way for those to switch positions. So we can basically, okay, so first let's list integer int list equals new array list. Let's copy the input and see what we get. Looks like 5,000 or so. So we can do this. Yes, you may import the class. Thank you. Int list dot add integer dot parse int scanner dot next line. Fascinating. Okay, cool. And what I also want is a list boolean bool list equals new array list, also 5,000. And I think this is probably going to be the thing to do. Bool list dot add false. Okay, so now I want to go through so while bool list dot contains false, we'll use that as our condition. Int I equals 0 while bool list dot get I is true plus plus I until we get to the right thing. And now what I want to do is I want to move the two things in concert. So I basically want to like move them back and move them forward. So what happens if I call Java list remove? Here's the element of the specified index and returns it. The subsequent elements are shifted left by one place. Fantastic. So we find the right index. Int what are they called? Value equals int list dot get I. And then what we want to do is get the value remove from both lists. We want to like compute where it goes. Compute where it goes. Remove from both lists. Add into both lists. So we want to do this until stuff. Okay, so let's see. So what index does stuff go in? So this starts in index 0, it goes 1, so its index is int new index equals I plus value, and then we want to percent is list dot size. That seems good. I also probably want this to be a linked list. Integer, is that not? Why can't you infer the arguments? Cool. Is this better? Cool. Because I think that linked lists are going to play better than array lists. Just for performance. So new index is that. Is that right? So 2 starts at 0 and jumps forward 2 and ends up at 2. Yeah, so now we want to remove it in both places. int list dot remove, and we want the index, which is I. Bool list dot remove I, and then we want int list dot add. We want the new index and value, and bool list dot add new index true. There we go. Let's start with the test input real quick and give it a shot. Let's make a little static helper function, private static void print list integer int list for integer I in, actually for int I equals 0, I is less than int list dot size minus 1 plus plus I system dot out dot print int list dot get I plus comma space. The last one we want to system dot out dot println int list dot get int list dot size, nope, int list dot size minus 1 that should be it. So at the end of this I want to so at the end of this let's call print list int list. In fact, this doesn't need to be an integer. This could be a list anything. Doesn't really matter. Here we go. Print list, bool list, system.out.println. Just to double check that we're doing stuff right. And I want to print all of this at the beginning as well. You can wrap this in if debug if we want. Sure, let's do that actually. If debug. Nobody's in the chat room that I'm ignoring. Fantastic. So we can actually just take this, put that there. Private static final boolean debug equals true. Fantastic. Let's run it and see what we get. Well, that's probably why, is that we're still doing level 19, level 20 part 1. Stop and rerun, please. And we're just not in a hurry today. No shame in that. Cool. So this is in level 20. Okay, cool. So if new index, probably while actually, just cover our bases. While new index less than 0, new index plus equals int list dot size. There we go. All right, do it again. So let's see. 1, 2, minus 3, 3, minus 2, 0, 4. 2, 1, minus 3, 3, minus 2, 0, 4. 1, 3, 1, minus 3, 2, 3, minus 2, 0, 4. 1, 2, 3, minus 2. What? What's going on? 1, 1, 3, 2, 3, minus 2, 0, 4. That's fine. 1, 2, 3. Minus 2, 0. Oh, so our final list is then wrong. Yeah, and it's because when we do negative numbers, we're not doing it correctly. It's when we wrap around, we're not doing it correctly. Is that right? So let's see, -3, 0, 1, 2, 3. Okay, let's just add a little debug here and see what happens when we get negative. This is going to be easier than trying to figure it out bit by bit. Debug, please. Well, that's okay, there we go. Now debug. Okay, so cool. So this is int list 0, which is 1, don't care. Here, let's debug there. Value is 2, value is -3. So where is -3? -3 starts here at 1. So it should go 0, which is the same as n. 0, -1, -2. New index is -2. Back to 0. Go back to... Yeah, what happens when it wraps around? So it's 0, and then not to n-1. Oh, if it wraps around. It's because 0 and n-1 are the same. So it's because it's circular. That's why it gets slightly weird. So we can't just go if it's negative, because this is 5,000, but these numbers are bigger than that. Do they get bigger than -10,000? Minus... No, so they only wrap around at most twice. Okay, so let's figure out some better conditionals here. So if it's let's say you have 10 elements, so it's 0 through 9, and you're at element 8 and it's 2. It goes to 9, and then it goes to 1. Okay, so what's the best way to make this argument? Is it only, The trouble is that the direction that it goes seems to matter. Let's look at this. So if we're at 4, then it goes over here, and it goes here, and it goes here, and then it ends up here. So the direction you're going, if you start at n-1 and you wrap around, then it should be n-1, 1, 2, 3, right? Or n-2, n-1, 1, 2, 3. If you go the other way, then you want to go, so if let's say you're -1 and you're at 0, then you should be n-1, you should be n-2. So every time you go around the break, you want to add 1. Okay, so we're actually not going to do the percent. So while new index is less than 0, add size -1, I think. Does that make sense? So if we're, let's say you have index 0 and you're at -1, then you want to be, your new answer should be, you get -1, then you want to add n, but you want to subtract 1, so you're n-2. If you're going around twice, then you're going to do that twice. That makes sense. And while new index is greater than int list dot size minus 1 new index minus equals int list dot size. Is that right? And then like plus 1? Is that right? So let's say our index is, we have 10 and our index is 9 and we want to add 1. Then we get to 10. So we should truncate. We need to end up in position 1 actually, because position 0 is, you're already next to that. Plus 1. Okay. And if we play around twice, is that going to work? So let's see. Notepad with A, B, C, 8, which are in position 1, 0, 1, 2, 3. Then 8 plus 3 equals 11. Which then we want to subtract 4. Really, we want to subtract. Let's see, where should 8 go? So 8 wants to go forward 8. So it goes 1, 2, 3, 4, 5, 6, 7, 8. Should be right there. Is that right? I think about 8 is 1. And it needs to go here. If it's 2, it needs to go here. If it were 3, it would come back to where it is. Because it's the number of gaps in the remaining set of numbers. There are n minus 1. There are 3 remaining numbers, which means there's only 3 gaps. Which is list minus 1. Yeah, okay. I think that's going to do it right. Okay. So let's run this and see if we get the same list of things. The wraparounds were gross. 1, 2, minus, okay, the beginning's the same. 2, 1, minus 3, 3, minus 2, 0, 4. 1, minus 3, 2, 3, minus 2, 0, 4. 1, 2, 3, minus 2, minus 3, 0, 4. 1, 2, minus 2, minus 3, 0, 3, 4. 1, 2. Oh crap, something got weird. 1, 2, minus 2, minus 3, 0, 3, 4. So then the next one to be grabbed is minus 2, which needs to go from there to here to here. Whoa, okay, so this is weird. So minus 2 goes before 1, but for some reason... Oh, but it's circular, so it doesn't matter because it's after the value 0. Okay, alright, cool. This actually doesn't matter because we still have... So 1, 2, minus 3, 0, 3, 4, minus 2 is fine. And then we have 1, 2, minus 3, 0, 3, 4, minus 2. So we're still cool. Now we have... Oh, 4 went to the wrong place though. So 4, 1, 2, 3 should come after 2. It's 1 short. Okay, let's debug for when we get to 4. Value 1. Wait, why is the value O? Because I'm hitting start over every time. Okay, so here's the last one. So the value's 10. The index size is 7, so index 3. What should it be in our current int list? So 4, then we want it to be 1, index 2, index 3. Is that right? So it's basically at index 0. Should be after. Goes before 0, goes after 0, after 1, after 2, after 3? Yeah, should be after 3. That was 10. Yeah, gross. Yeah, yikes. Is there a way for me to think about this? Okay, so let me think actually. What's a better way to do it rather than this grossness? So if we remove it, its index is the number that was before, and then we want to add some number, and then in the under before that. So what if we go what's value? Percent. That makes this 10. So it's at 6, 0, 1, 2, 3. Why does that work? Does it only get weird if it's negative? But it shouldn't be 0. It needs to be 1, 2, 3. Oh, because it's at position 6. Wait, why is I 6? Is this like already wrong? What's going on in the console? Oh, because for us we're here. Okay, cool. So this needs to end up with position 1, 2, 3. This needs to end up in position 4. Yeah. So can we just go int list dot size -1? Does that play nice? And then we get rid of this part. And for this part, we can just do this because we're already doing that by the way we do the modulo. So now what happens if we stop and rerun? Okay. This is fine, this is fine. 1 minus 3, 2, 3, minus 2, 0, 4 is fine. 1, 2, 3, minus 2, whoa, whoa, whoa. So minus 3 didn't move enough. Minus 1. Yeah, because everything's modulo this. Yeah. So now run it. Then we can just look at the bottom and see whether or not we get the right answer. Minus 2, 1, 2, minus 3, 4, 0, 3. Seems fine. Okay, so we're good. So now after the value 0, so int start index equals int list dot index of 0. We want to add them together. Grove coordinates plus, we can just do the stuff right here. So we want int list dot yet start index plus 1000% int list dot size. And we want this. So we can do this. And then we want plus, and then we want the same thing. 2000 and 3000. So 2000, 3000. So let's try it on our little data real quick. Turn debugging off if we want. Row coordinates 3, fantastic. Let's try it for our bigger array. Okay, man. Okay, let's turn debug off real quick. Stop and rerun, please. It's just taking too long. 5,000 numbers, each being moved. Shouldn't be that long. Why is this taking so long? Let's just give it a minute. It's already true, so we're fine. This part doesn't need to exist. Grove coordinates are apparently this. Let's give it a shot. That is correct. I got rank 420. That is... We're gonna blaze it. 420, blaze it! Right, Mel? Yeah, she's reading her book. Part 2. The Grove coordinates seem nonsensical. While you ponder the mysterious elf encryption, you suddenly remember the rest of the decryption routine you overheard at camp. First, you need to apply the decryption key, this. Multiply each number by the decryption key before you begin. This will produce the actual list of numbers to mix. Second, you need to mix the list of numbers 10 times. The order in which the numbers are mixed does not change during mixing. The numbers are still moved in the order they appeared in the original pre-mixed list. So if -3 appears fourth in the original list of numbers to mix, -3 will be fourth. To move during each round of mixing is the same. Using the same example above. Blah blah blah. I'm going to use some in the same way. Okay. Apply the decryption thing. What is the sum of the three numbers that form the Grove coordinates? Okay, so we can pretty much copy this and make a small tweak and we'll be done here. Everything through the return, copy, can leave print list alone, go here. So one thing I want to do is I want this to be a list of longs now, and I want this to be a list of integer, and instead of bool list, gosh, let's call this index list. Long dot parse long. Please parse the string. Thank you. Looks equals 0 I plus plus. Great. So we're good. Okay. So now instead of while index seems false, we need a slightly different thing. We need for int encryption run number equals 0. Encryption number run number is less than 10. Plus plus encryption run number. Cool. So that part's all fine. So this is all cool, and so now instead of while this, it's going to be for int I equals 0, I is less than int list dot size plus plus I. Okay, so the right index is going to be int index equals 0. Equals index list dot index of I dot get index. It should be long value equals this. Long new value is still this. Also, we need to long to parse long, blah blah blah, times this. Cool. Let's play some more music. This is all the same. We're gonna just insert the index. Dot, I don't know. Int. I think we can just cast it. I'm already on part 2. And I got rank 420 on part 1. Blaze it. Yeah.
I'm gonna go upstairs and I
Okay.
wanna send you a message. Love you.
Love you too. You're gonna go upstairs and what?
I'm gonna send you a message on Face.
all should be the same, because we're already doing this nonsense where we just find the right index and insert it. So let's try running it on the sample input and see if we get the right answer. Which again should take a little while, but that's okay. We'll take a little while on the real answer. Call this J. Alright, I will play nicer. Oh, well, that's if we run part 1 again, we will get part 1. Index out of bounds, index -1, size 7. Where? What's going on? Start at 0, right? Plus J, great. See if that makes it run better. Nope, same exact issue. Okay, let's debug, see what's going on. What is the index here? I 0. The index list is 0, 1, 2, 3, 4, 5, 6. That seems fine. Again. Index is 0, so we're still cool. And again. Okay, why is the index -1? I is 2. What's our index list look like? Okay, so let's stop and debug again, because clearly something happened after that second run. So our index list is 1, 2, 3, 4, 5, 0, 6. Somehow the 2 went away. So our index was 0. So now we're trying to move this huge number. I'm going to do some stuff to it. Oh, and this needs to be list.remove index. That's fair. That's definitely fair. Stop and rerun. If coordinates are negative, that's not good. We have to multiply? Multiply each decryption cube over again. This will produce the actual list of numbers to mix. Okay, let's stop here again. Let's debug. So let's look at our int list. 811, 153, 1623, minus 243, 243, minus 162, 0, 342. So if we go here, we play. Okay, now what's the int list? We're already, no, we're okay. 0. Okay, so after our friend draws node fixing, we were already wrong. So we're mixing wrong. Yeah, we're just like totally wrong. Okay, so let's see. Let's stop and debug again. Which is cool because that's 0. So let's go to here. Play. Okay. Crap, I is 1. Okay. Well, we goofed. Okay, we're at 0. The int list is fine. So let's Wolfram Alpha this. So 0 plus 811 589 153. Cool. And if we want that, %6. Should be 5. Let's see if we get that. What's the new index? New index is 5. So now, part 2, index is 0. Yeah, what's... Okay, let's do 1. Let's turn debug on. Let's see what happens. Okay, so yeah, we still just have a different answer for what the mixing is happening here. Let's look at the stats real quick. Yeah, okay. Back to problem 20, please. Okay, we're multiplying by the right number. 811, 589, 153. Fantastic. Okay. Oh, did I click record? I did not. Okay, well, we're going to be downloading this from Twitch. That's fine. So what is the actual list of numbers to mix? So that becomes index 5. Sure. And the next one to mix is 1, which is this one. So if we say 1 6 2 3 1 7 8 3 0 6% 6, answer should be 4, which it does end up in 0 1 2 3 4. Great. Now where does 2 go? 2 starts in 0. So now if we go minus 2 4 3 4 7 6 7 4 5 9 percent 6. On this percent 6. Mod 6 3 0 1 2 3. Whoa, okay. Something weird is happening with that negative number. Oh. Long I plus value percent. Then int. Does that play nicer? Actually, first let's get rid of this and let's see if the types play nice. If I instead of that went value plus I. Now do you get mad? No. Long. Yeah, so now you get mad. Int of this, please. Int of this whole thing. Long. Okay, cool. So now what happens if I play this? Now do we match? No, we still don't match. Okay, let's go back up. So we're at this one, and we think minus 2 4 3 4 7 6 7 4 5 9. Should we just copy, we paste? We do this. Answer's 3. 1 2 3. So we remove ourselves. Should go right after this. So what's going wrong there? Some weird class catch bullshit. Yeah, this one's still ending up weird. Okay, so let's 1 2. This is the third one, okay. So the value is negative whatever. So what do we get? New index is minus 1. Okay. Probably shouldn't be I plus value. Probably should be index plus value. There we go. use those i's in the indexes. Okay, now what happens if we stop and rerun? Now do we get the same list? 0, minus 3, minus 1, 2, 1, 8. Okay, so now it works. Wonderful. Set debug to false. Set number of times to 10 and run for me. Give me an answer. Well, first of all, let's go back to this. Rename this long list. Great. Long list, start index. So it's all of this is inside the parentheses. That should be fine. Okay, so let's take this. Let's do this. Set debug to true, and we'll just get 10 different ones. Well, why is this 1? Oh, because I put 10 in the wrong place. That would probably do it. Cool. So now if I run again, row of coordinates, still wrong. Okay. So 8, 1, minus 2, 2, minus 1, 0, 3. 0, minus 2, 3, minus 6, 2, 1, 8. 0, 2, 1, 3, minus 2, minus 6, 8. Let's go down to the last one. 0, minus 2, 1, 3, minus 1, 2, 8. So it's clearly just this last part that's wrong. So let's debug there. Don't care about this anymore. Cool. So while we're here, our long list has 0, minus 2, 1, 3, minus 1, 2 thing. So 1000%, 7, 6. So if we have long list dot get 1000% 7, so it should be 811 whatever. And what about 2000% 7? The answer should be whatever. 3000% whatever. Cool. So now, what about this is not getting that same answer? Start index should be 0 here. Oh, index of 0L. Okay. Stop and rerun. Okay, so now it does the right thing. Let's turn debug off. Let's put this in, and then let's let it run for a little bit because it does take a little while. Actually, now that we've moved the debug just into the outer one. Okay, well this apparently should be our answer. Let's give it a shot. That's right, rank 782. Ooh, yeah, we nailed it. Ooh, I'm gonna have time to get to that McDonald's, get some french fries, get some Coke. Ooh, I'm feeling good. Alright. And 782 on this SARS leaderboard. I am actually pretty proud of that. 21 minutes. Yeah. And 15 minutes. Yeah, that's unsurprising. Yeah. Nathan Fenner gets both parts. 4 minutes and 5 seconds. Lol. Okay, well, we're a little slow today, but that's okay. And a look at our personal stats. Oh. Total stats. Yeah. Oh yeah. Wonderful. You'd love to see it. Look at our private leaderboards. No chance. Nobody's staying up late at night to do this except for me. Okay. Yeah, I'm missing all but 1 star here. Ooh, almost the perfect run. Okay. Let's take this and go ahead, put it in the problem statement, and we can get rid of this for a second while we fix some of this stuff. Go here. Starfruit grows. File is encrypted as bolded. Maybe you can decrypt it. Mix it. To mix a file, you have to do some stuff. The list is circular. For example, the one in sequence like this, the one moves forward like that. To move the -2 sequence like this, the -2 moves backwards 2 positions, wrapping around like this. Fantastic. In the orders they originally appear. Wonderful. Consider this encrypted file. I will consider that encrypted file. And this file proceeds as follows. Blah blah blah. Blah blah. This is 3. 2. -3. 4. 0 bits. What is this? Actually, part 1 was 14,000. Fantastic. Growth coordinates seem nonsensical. First, you need to apply the decryption key. This. Multiply each number. You do it 10 times. It's in the same order as above. Yes. Things. 1,000th after 0 is this. The 2,000th is this. And the 3,000th is this. This produces this. Okay, what is the sum? 3 numbers. Answer was this. Fantastic. Alright. Let's do a little bit of code commenting and then we're good. Let's read in list. Create list of have we touched this index yet. Find the right index. The bool list works because untouched items stay in order relative to one another. The value at that index, compute where it goes. This is done using list dot size -1, since you can essentially treat the list as excluding the current item for the purpose of moving it around. Rectify negative values. Remove from both lists, add into both lists. Print stuff out. Growth coordinates, fantastic. And I basically want to provide a similar set of instructions here. Read in the list and keep track of their indices. Fantastic. Run mixing on the list 10 times. The right index, which matches I, the value at that index. We're going to copy the compute where it goes part. Here we go. Do this real quick. Add into both lists. And all of that is self-explanatory. Okay, let me explain what's going on. So we're given a list of integers, and we want to make it so that each integer moves forward or back as many spaces as the value of the integer where we consider the list is wrapping around. So one thing you'll note is that means that 0 and n are the same thing in our list, which for a while I was worried about, but because of the way the answer is computed, that doesn't actually matter. So, what I did is I read in all the numbers, and I read in a list of booleans of similar length. And then for the first part, what I did is I just took each integer, I modded it by the number of items minus 1, so like excluding itself. Because if you consider, like, if something starts here, if I want to move it over 1, 2, 3, 4, 5, 6, 7, 8 gaps or whatever, I'm only considering the 5 other items. I don't care about the one item that I'm moving. So I want to consider, like, what place does it go in modulo these, and then I can just extract and insert because lists allow insertion in between. And the Boolean list is useful because let's say I have 5 values and I pick one up and I move it. I can set the index similar to this to be false. And the nice thing is no matter where this thing goes, so actually let's say we have 6 and I move this one around and it goes somewhere, whatever. Well, now I have, a bunch of falses, and then I have a true right here, which means I've already touched it. So what I do is I start from the beginning, and no matter where I moved this one, all of the ones that haven't been touched yet stay in the same order. So now if I move this one and it goes somewhere else, now these two are gone, they've gone somewhere else. Well, these have all stayed in the same order. No matter where I insert these, if we just count these ones, they stay in the same order. So I can always just grab the first false that I find in the list and just move that one. And then no matter where that gets pulled out, when I insert a true, and then all the other falses have stayed in the same order. So I just go to wherever the next false is, no matter whether or not it's moved forward or backward or whatever. And so that's all it really takes. And then you get the index of 0, and then you mod by some stuff. Oh, 1 second. I think I did something nice there with the formatting. I don't know. What did I do? Okay, whatever. Whatever I had done was awesome. Control Y. Redo. Okay, undo it. Okay, great. So that's all great. So let's move this down to the bottom while we're doing it. So for part 2, it's pretty similar. The only thing is you have to run it 10 times, and you have to multiply all the original things by this magic value. So the only stuff that changes is 1, we had to deal with longs, so we got a couple of issues where we weren't parsing longs correctly. And 2, if you're doing this by actually picking stuff up and inserting it 1 over every time in the first part, like multiplying it by that means this is going to take forever. But given that we were already using modulo arithmetic, this is not really a problem. So once we do all of that, the only other thing is you need to run this over and over again, and you don't use the order of the list. Let's say you run mixing once. You don't then use that order of the list to then mix again. You use the original order, and then you mix that again, like in that order. So the only thing I had to do is I had to move my Boolean list and instead make it an index list, and then when we go through, rather than just finding the first false in the list, we actually say we know there's a 0 through n-1 here. Give me the index of that one, which again we can use list.indexof, and that ends up being fast enough because this list isn't very long. And so then when we run the same thing, we do the same stuff, we get the same answer. So it's pretty easy today. Again, happy to have scored faster than 1,000. That's usually my litmus test for whether or not I'm doing well, and top 500 is pretty good. It's not my best one. My best one was 16, which, 16, 655, 420, 782. No real complaints there. So I think that's all I've got for you guys. So let me go ahead and step away here, and hope everybody has a good night.